Hello and welcome to this third webinar from Real Resilience on an aspect of reel-to-reel recording. I thank very much the people who have already joined me on the Q&A this afternoon, and thank you very much for your questions. My name is Ian Betson. I run Real Resilience here in the UK, and we offer service and support of reel-to-reel tape machines. And if you ask me nicely, I'll do cassette decks as well. This webinar is on fixing machines and the fault finding techniques and maintenance techniques that I use in a whole variety of machines that I get through my door. Now, a little bit of apology before we start that I'm not going into specific machines and I can't go into stock faults. However, if you'd like to send me your Q&A, I would do my best and I will answer them. Perhaps if we haven't got time in the webinar now, but I will get back to you via email. So if you could perhaps contact me via the website with your question, that will be very, very helpful. However, the techniques I will be covering are applicable to all tape machines. When you think about it, from a mono quarter-inch machine up to a 2-inch 24 track, the ethos of a tape machine is basically the same. It is mechanically moving a tape, which is covered in rust, past a record head to impart the audio signal onto that tape, and then past a replay head to get the information off and replay it. So that ethos is the same regardless of the machine that we will be talking about. Before we start, I thought I'd let you sort of give some advance notice to those who have booked. I have some machines that I have for sale. If I just put them up on the screen here, that I'm representing for a client and also my own machines. A couple of Revoxes here. We've got a B77. It's the high speed Mark II version, and then we've got an A77 on the right. As you can see, they've had some life, so that will be reflected in the price. But I have investigated them. I know that they work. I know certain aspects like the heads and what have you are in quite good nick. But as you can see, there are some parts missing, for instance, on the A77. That machine, incidentally, has got the case and it's got the speakers built in, and it comes with this huge, great padded flight case as well, so that will be reflected in the price. This machine is a TIAC A3300SX. I've decided to sell it. It's a real shame because I'm using it in my workshop as a listener after working on it, and it's a lovely little machine. Had a lot of work done to it. New pinch roller, head relap, completely cleaned, partial recap, and it's also had all the mechanics done on it and electrically safety tested and lined up for SN468 tape. And finally, on this bit for a couple of machines I've got for sale, a couple of Tandberg Series 15s. The one with the black spool hubs, again, I'm representing that for a client. Apart from just checking it works, I haven't done much work to it. The one on the right is my machine. I just bought it, came as an impulse buy with a few others. It's had a new drive belt, completely clean, lined up. Got a little bit of a patina, I think that's what the antiques people say, on the spool platform. But they'll make two very nice machines if you like collecting Tandbergs. Drop me a line via the email if you're interested. I'm not going to go into any further details on this webinar about them, but if you're interested, I'll be happy to talk further. So, open reel tape machine fault finding and maintenance techniques, the subject of this webinar. We'll be covering what I call the roadmap of what you need before you set out to find the faults, isolate them and fix them on your machine. The approach I take, the tools, the rule of halves, you'll learn about that, and also thinking outside the box in terms of trying to isolate a fault or indeed discovering faults on the machine, and asking yourself what's changed. These are all aspects and techniques that you can use to get in and isolate the faults and fix them. And then finally, I said the Q&A session, I've already got some questions in, and I'll be happy to answer those if you send them in live, or we'll cover the ones that have already been sent in. So let's push on. Service manual sources. That is your roadmap. Wherever you start, before you jump into thinking what could be wrong with my machine or machines, if you have a collection, you need to know, firstly, how it works. So I would suggest you get the operations manual and be au fait with the way it works. You'd be surprised the number of faults I've encountered in my career that aren't actually faults. They're kind of operator error or finger trouble, as we might say, where that the people think this machine is not behaving as it should do, it must be faulty. In actual fact, they haven't got the machine set up properly. So get the operations manual of your machine. That's most important. Service manuals, you might be lucky and get the originals. That's an original manual for a Studer B67. Regrettably, I had so many original manuals way back about 10, 15, 20 years ago when tape machines, no one ever thought of them. It was the last hurrahs in the 90s, and I threw a lot away. How silly was I? But I've still got a few originals. But the other resource that I use and can recommend is hifiengine.com. If you're into your turntables, I think there's a sister site called vinylengine.com devoted to those. Hi-Fi Engine, it's a free resource. You need to register, and I think there is a limit on how many you can download per day. I think it's about 5 documents, but there's a massive library of all types of machines, and interestingly, in different languages. People all over the world have uploaded them. And just because perhaps a manual is in German or in Dutch and it's not your first language, I still download those sometimes, because sometimes it's the only resource I have. And I'll come on to that in a particular machine where I had to fix, and the whole manual is in German. And unfortunately, my German is klein, very small. But you can download them. The other thing I suggest you do, this one is for the Sony TC765, is print them out, print out the manuals. And the reason for that is that make amendments to them. Just because you've got this service manual, it's not the be-all and end-all of machine maintenance. You will find other bits sort of behind the scenes as your experience grows, and you might need to come back to a particular fault on a machine. You think, what did I do last time? This, as an illustration, is, I'll pop this on the screen for you, is from a Revox A77 manual. You can see the circles in red. It's rather scrappy handwriting, but it's telling you to check the balance adjustment and where you take it from. And I've written there, take the outputs from pins 3 and 5 of the DIN socket. I'm not having to reinvent the wheel, go over trodden ground again. When I come to line these machines up, I've already got that information and I've just jotted down on the manual. And that is the advantage of printing them out. Another example here, this is the circuit diagram for an A77, and as you can see, I've circled a couple of bits there. Studer Revox manuals are very good, and I have to say TIAC and Tascam I find are quite good as well. But you'll see there, they've got some diagrams that go, or some lines that go off the to another drawing. Well, where do they go? Rather than having to flip through all of the other diagrams to find, for instance, where DN1 goes to, or DB1, as we've got written there, I've written up there to power lamp. I know it goes to the power lamp. And similarly at the bottom there, I've written down, you might be able to see it there, these are the kind of voltages when a machine is working properly that I'd expect on a spooling motor. Those kind of things might be in the manual, but it also might be things that you find out as you go through and work on the machines and get experience. Other knowledge sources. The Tape Heads Forum, and there's also, I know I'm UK based, but it is the internet. You can go anywhere in the world nowadays. The UK Vintage Radio Forum, that's another a good place. And gearspace.com. You might have heard it was Gear Sluts, but I think political correctness has kicked in here and they've renamed themselves to Gearspace. But they're forums of like-minded people who are obviously posting their findings and posting their questions about various machines. So sometimes if you've got a particular fault on a machine and you're scratching your head, type it into the search box of Google or what have you and see what comes up. And indeed, these forums do. The other thing I do as well is on these forums, it might be one I've got here. telling you about the issues with the end of tape switch on a Revox A77. You won't find that in the manual because, you know, the manuals were designed for when the machines were new, not 40 and 50 years old. And you can't get those end of tape sensors anymore. And they do have a habit of failing, but you can revitalize them. There's some issues here on how you can solve that problem with the photo sensor on an A77. It was on the forums, so I've printed it out, popped it into a Word document, and it goes into the manual. All things that you think, I know what that is, I've got the information already, I don't need to reinvent the wheel. So really, they are your roadmaps that you need to start with before you go anywhere in taking the covers off or pulling all the switches off or deciding even perhaps the machine has a fault anyway. What have we got on the spacecraft that's good? What does that mean? If you've seen the film Apollo 13, that's the one where Apollo 13, strangely enough, was on its way to the moon, and they decided to do some routine tests, and the spaceship blew up. And they're therefore worrying how they're going to get the astronauts back home. Fortunately, as we well know, it all ended superbly for NASA. However, there's a scene in that film where Gene Kranz, he's the flight director, he's brilliantly played by Ed Harris, and everybody's kind of headless chickens, they're not quite sure what's going on. And he just says, firstly, calm down. Let's not make second guesses. Let's not make the situation worse. And he also says, let's look at this problem from a view of status. What have we got on the spacecraft that's good? And this is something that I apply to tape machine fault finding. What have I got working on the machine that's good? Sometimes you can get a machine, you think there's too much that's working properly on this machine for it to be a fault. And again, it can come back to operator error or something that's just a strange fault that might just manifest itself intermittently. But the first thing to look at is what have we got on this machine that's working? Now, to illustrate that, I've got a Sony TC765 video for you. And I will play it in a minute. It came in when with the owner saying the supply spool is running fast. And to first examination, it does look like that. Take a look at the supply spool and what it's doing. But then also have another look towards the end of this video as to what the machine is actually doing. So here it is, a Sony TC765. We just start it and I'll put it on the screen for you. There we are, it's throwing loops. And notice what the reel is doing. It's now slowing down, close up there of the loop being thrown. And it's come to a halt and now getting tugged along by the take-up spool. So, what could be the problem? The initial reaction could be, well, the take-up motor, the supply motor, I should say, has failed, or maybe the motor run capacitor has failed. If you don't know what a motor run capacitor is, this is a motor run capacitor. Not getting into too much technical detail at the moment because I've got so much to cover. Suffice it to say, they are put in to keep the motors running, and especially depending on what mains frequency and what voltage is in your country, they will vary in rating, but they're there to help the motors. We'll just leave it at that. But if they go faulty, and they do because these machines are so old, the motor will come to a halt. Or you just might think that the power supply to that motor has completely died. I'd like you to watch another video now. This is the second video, and I'll just start it, of what it's doing in fast forward. Notice it's pulling away quite happily. I do apologize for the video here, the strobing. It's going into rewind now, and as you can see, that supply spool is going perfectly well. But when I put it into play, there we are, it's back to its old tricks again. It is throwing tape loops. So it's probably not the supply motor. What have we got in this spacecraft, on this tape machine that's working well? Well, we know it rewinds and fast forwards perfectly okay, but it's still doing this problem in play. I did check the spooling motor, motor run capacitors, I should say, on both both motors. and they were both fine. A quick test, no problems at all. And then I looked at the circuit diagrams, looked at the manual, and realized that the motor run capacitors are only switched in on that particular machine when it's in play. When it's in rewind and fast forward, they're out of circuit. They're not used at all. And how they're switched in is via a relay. So you think, okay, the relay is a good example there. I checked the supply voltage to that relay, it's perfect, and found that the relay had jammed over. The relay on the take-up spool was working perfectly, hence why it was it wasn't throwing tape loops in play. But on the supply side, it wasn't switching over and therefore not working. Change that relay and the machine is fixed. But that is a case of not just jumping in, looking back, what is working on this machine, the spooling motor's fine, and taking that approach to isolating the fault and fixing it. So what have we got on the spacecraft that's good? It's a thing as well that was taught to me when I did my training way back in the 1980s, that not to charge straight in. We had a Studio A80 whose sole use in life was to be taken apart by us trainees and put back together. I think the trim pots probably wore out for us lining it up all the time before the machine ever wore out mechanically. But we were taught not to charge in, stand back, what is working on the machine. And it is a technique that holds so well. Another reason why you shouldn't charge in, there seems to be two things, and I detect on the forum that on forums that I go on, that there seem to be almost cure-alls for any ill on a tape machine. One is head relapping, and the other one is recapping. Now, I'm not averse to recapping. They do need doing. Components get old, as I've already mentioned, and they do need doing. But there seems to be this case of, I've got a dent in the side of my tape machine. Recap it is the response. I've got a scratch in the panel. Recap it, that will solve the problem. If you're going to charge in and start recapping a machine and changing all the components, how do you know? And there's a lot. For instance, on a big 24-track machine, there could be hundreds of these components that you're changing, that you're not going to make a mistake, or perhaps there could be a cracked circuit board or something that, to put it bluntly, you make the machine worse than when you started. You need to start from a point where you've got the machine that's faulty, a known state. This is what it was. Yes, it's faulty, but I know what known state it is. If you jump straight in feet first by recapping as the first option, I'm afraid I think you'll get yourself into what might call poverty street, really, or some people say certain creeks without a paddle. Riffer caps, incidentally, why do we call them Riffer caps? If you're not aware of that, that's because they're made by Riffer. I do apologise for the quality of this picture. The close-up's not that great, but this is a particular one that's gone bang. You'll see capacitors here. This is a good example. Oh, just dropped one on the floor, but here's a good example there. If you could see that. It's gone very sort of grey brown. The other ones you'll see, and this doesn't matter what tape machine it might be. They were very popular in German machines in the 60s and 70s. Capacitors called Fracos. They're just the company, same as Riffer were, that made them. And frankly, the gloop starts coming out of them and they start going home. Now, moving on as to why I'm not a great fan of globally jumping in and recapping is because I had a customer brought a B77 to me, and he said, I had some work done on it and now the machine doesn't work. This is someone's attempt at recapping a B77. As you can see, the top right-hand side there, that's the oscillator board. We know it's the oscillator board, but we see that large grey inductor block there, and that's that will supply the frequency for arrays and the bias current we need. You'll notice there's some black wires come off. That's on the right-hand side, the green side of the board. These wires were soldered directly straight onto the board. They are, in actual fact, the wires to the record head. The ones over here, they go to the erase head, but who had ever done it, those wires should go in there. they had just bodged them straight away back onto the board. As you can see, the other boards, this is various attempts at putting capacitors that are completely too small for the job. So because they weren't fitting the holes, they've just put them onto the back of the board. And on the right-hand side here, you can see, although they've replaced the trim pots, there's two that frankly will make lining the machine up although electrically they work, they'll make lining the machine up very, very difficult. It's no surprise that this machine wasn't working. I had to completely strip that lot off and start again. This is a before on the left, or so before on the left-hand side. You can see those relays that are used to switch the bias current through to the record head when the machine's in to record. And this is the result after I'd reworked it and put the capacitors on the right value in the right places as well. These two little PCBs at the top here, incidentally, are made by revoxonline.de, and they are replacements. You can't get the relays for B77s anymore. They don't make them. So they make these standard relays with this sort of PCB converter. And very nice little boards they are too, and a nice elegant solution. So that is the reason why I am not a great fan of globally jumping in and recapping. Yes, if a machine, you're getting into it, you're finding you're getting more and more of these brown capacitors, of course, replace them. You might need to take the decision at the very least, replace all the capacitors on that board. Obviously, if you're finding brown ones, you replace them. But you might then say, there's too many here, I'm going to replace a lot. Just be aware of what you're doing and the state of the machine before you started, and then the state when you've finished. It's all very well talking about recapping and doing that work. What tools do we need for the job? Well, firstly, before we start, I must say a health and safety note, really. When you start taking the covers off tape machines and delving in there with tools to do what you need to do, just be aware there are some lethal voltages flying around in machines. At the very least, they are plugged into the main supply of your country. Some tape machines have spooling motors that use 125 volts AC. Just because the mains comes into a nice panel doesn't mean to say it's not exposed mains on the back of that panel where the connector is, and also goes round to the power switch inside the machine. We are dealing with machines that are from a different era, really, of health and safety, and manufacturers have to adhere to a lot more safety requirements, as they should in the last sort of 30 years. But some time, especially for machines from the 1950s and 1960s, I wouldn't say manufacturers play fast and loose with their build quality, but I don't really think, I mean, you probably saw the little sticker on there on many a machine, you know, only to be opened by qualified service personnel. But even then, that qualified service person would probably be wary of what they're doing once the cover comes off. The other thing is, if you are working on a machine and you need to switch it off, I do strongly urge you do not rely on just switching the machine off from the main switch on the front. Take the plug out if it's a captured lead, obviously from the wall, or if it's from the machine itself. Main switches can get knocked on, and as I said, just because the mains goes in on a back connector, it might work its way through to exposed mains under the main switch. You pick the machine up, and you could be wiring yourself up to the mains of your country. I have done it. It's 220, 240 volts in the UK at 50 hertz, and it's a strange sensation. I have survived, but I wouldn't recommend that you go ahead and do it and try it. The other thing to bearing in mind, back to capacitors again. Power supplies have capacitors in them which have an action of smoothing the main supply. The AC supply, which is like a waveform coming into the tape machine, goes to the transformer, steps it down, it'll then go to a rectifier, which turns it into a DC signal, which is what the electronics and the controls on their tape machine like. But that DC signal will be what we call rather choppy. Instead of being a nice smooth DC level, it could have sort of almost like a sawtooth, or it could be less than smooth than we want. So we use things called smoothing capacitors to do that. How a smoothing capacitor works, again, not getting into too much detail, but imagine you have a bucket of water with a hole in the bottom. and that is our capacitor. The water is running out in a steady way out of that hole in the bottom, and everything's fine. It's a nice smooth flow. A transformer and rectifier are throwing water into the top of the bucket and splashing it all around, and it's running smoothly out. That bucket with a hole in it is our smoothing capacitor. Now, smoothing capacitors are, by definition, big things because they have to have a lot of water, a lot of charge in them. This is a 10,000 microfarad capacitor. Capacitance is measured in farads, but because that is a big measurement, they call them microfarads. But 10,000 microfarads is 10 farads. That's still quite a big, a lot of charge in this thing. And some machines will have 3 and 4 of these things to act as the, for all the different power supplies, to be the bucket that's giving us a smooth DC water flow. They will hold a charge in here even when the power's switched off. And you go in there with perhaps a screwdriver, or even if you've got a ring on your finger and you put your hand in there and bridge these, they will go off with a big crack and they will burn you. There's a lot of charge released in there. Smaller ones like this are nothing to worry about. You can quite honestly bridge the connector, bridge them, hold them, and they're fine. But even now, you can see why I've got a piece of tape across these. And if I was taking them out to replace them, I would still make sure that they're discharged. But big smoothing capacitors, be aware of those in your machine. So that's the safety side. Let's have a look at some tools. I'm not going to stand here and take up your time on the webinar and tell you about screwdrivers and pliers. I'd hope you've got a basic set of tools if you're getting into your tape machine maintenance. Be aware, of course, if you've got an American machine, they're very much likely to be imperial measurements, and whereas Japanese and European machines are likely to be metric. If you've got a few old British things, I think they might be imperial, or even things called Whitworth. I never got my head around what Whitworth threads were, but we use those in sort of like when Queen Victoria was on the throne in Britain. But you'll get sort of imperial measurements there. Things I could suggest, well, if you're going to be doing your recapping, you probably want a soldering iron. The only ones I recommend, I'm not tied up in any advertising for them, Weller soldering irons. They're lovely irons, and they hold constant temperature, and they're very nice. They're also, you can get them to have what's called the earth lifting on them, on the iron itself, not on the transformer, which can also help if you are you're not short-circuiting things within the machine. If perhaps sometimes you do have to work on them when they're live, if you're just taking the odd wire off and you don't want the shorting action of the soldering iron going onto the circuit board. Solder itself, again, another little health and safety check. We are working on machines, again, that are 30 and 40 years old. They would have used leaded solder, tin lead solder, 60-40 composition. Lead, by its definition, is nasty stuff. Don't eat and drink when you're soldering, especially eat. You don't want to get any of that on your fingers and then into your hands. So be aware of that, and also dispose of it properly. There is unleaded solder that is available, but unfortunately you can't mix the two. If you've got a PCB that's been soldered up and you're recapping it and it's all been soldered with leaded solder, you can't put unleaded solder in its place. The two don't like to mix. Modern machines, we know about our Ballfinger and our Thorens, they're very likely to be built with unleaded solder now. Between you and me in the webinar, I happen to hate unleaded solder. I do take on board everything about leaded solder, and lead is nasty stuff, but I feel unleaded solder is just as bad. It runs hotter. You need to run your iron at a lot higher temperature. I think leaded solder is about 325 degrees, and unleaded solder is getting on for 400, which means you've got a chance of wrecking the PCBs when you solder. And the other thing is, there's a thing in all solder called flux, and it's used to get rid of all the oxides on the solder surfaces and make the solder flow. And unleaded solder flux smoke is just it's just like clouds of the stuff, and I don't actually think it's particularly good for your respiratory system. If you are doing a lot of soldering, I also stress, get yourself something to extract the air to take it away, because you don't really want to be breathing this stuff in long term. But unleaded solder is just horrible for that. The other thing is, with leaded solder, you get a blob of it drop off, it just goes into like a little silver ball, and that's it. Unleaded solder stays hot. It's like napalm, and I've had it drop on my hand before, and I'm trying to flick it off as it's burning its way into my skin. It is not nice, and I've got the scars to prove it. What other tools have we got? Other basic stuff. Get yourself things like a paintbrush. Just to get all the muck out of all the dust and all the tape swarf that we have that comes off these machines. Other things you might want to consider: nut spinners. Don't resort to a pair of pliers to move the bolts. Nut spinners, they're proper things for the job. You can put them down. You can use them to adjust the azimuth on your head, on the heads. Anywhere that's got the has got nuts to put on there, you can tighten them up appropriately. Again, you'll need metric imperial depending on what your machine is. Well, then we've got other things such as cotton buds. I buy these in large packets and just use them, whether it's cleaning your pinch rollers or cleaning the tape heads, through to just greasing the machine. I had a question come in about what lubricants and grease should you use on your machines. Well, first thing is, we'll find a lot of machines, they are old, they have got solid grease on them. So you need to get rid of that grease and lubricant first before you can put the new stuff on. And that's what I'm using, IPA. This stuff comes from my local electrical factory in the UK. I'm sure you can find it at your local outlets. 100% pure alcohol, comes in a spray tin, same stuff as I use, and if you watched other webinars in the past for cleaning tape heads, but it's great for just putting on a cotton bud or even lint-free paper and getting rid of all the grease. Good old contact cleaner. There's a lot of people talk about Deox as well. I haven't tried it, I must confess, but I'm happy with this contact cleaner. Spray it in, give the switches a good clean, and that can give your machines a second life. Pinch rollers, I've covered really this in a previous webinar, but that's the stuff I use. It's called Platin Clean. It's designed for copiers and printers, and it is better than when I first started doing tape machine maintenance back in the late 1980s, and particularly the solvents we used. That stuff is great. I'm sure you can get similar products. I said I will put all these, if you want to know what I use, I'll happily supply you the information and where it comes from. I mean, a tin like that is about $2.50 if I remember, and I buy it in sort of 3 or 4 tins at a time. Platin Clean for copiers and printers. Cleaning up your machine. Again, foam cleaner. This is aqueous foam cleaner, water-based. Yes, we don't spray it around when the machine is powered up, of course, but it's great. You could use it on your pinch rollers and your rubber parts and machines and your belts, especially if you're getting grease and your lubricant, or have accidentally got it on a roller. Good old foam cleaner, either sprayed on to clean up the case or to a cloth is fine as well. And finally, the other lubricants I use white lithium grease, which is the same stuff that you get in, if you've ever taken the lid off your CD player or your DVD player and you see the sled drive that takes the disc in and out, it's lithium grease. Again, don't eat while you're using it, but it's ideal to lubricate all those sliding parts. Don't use oil on those sliding parts, but all that happens is that that stuff will run off. You want grease on sliding parts. Rotational parts, you might need to use obviously the right lubricant. Moving over here, the lubricant that Studer Revox recommend, and indeed you might find this in your manual, that's a particular brand of lubricant they recommend. Unfortunately, because of the age of the machines, you might not find that's available anymore. But the stuff I use is Kluber's Isoflex PDP 65, and there's also, they did for their earlier motors, I think they're pre-1974 motors, GLY 210. There's a document on my website called Studer Technical Protocol 174, and that details, if you've got a Studer Revox, the type of lubricant you need on your spooling motors. This stuff is thinner than water, and you really don't need much of it. You just need a little drip on the rotational part, and that's all. It will work its way down. I actually use just a swab of it with a cotton bud, even on tension rollers and other moving parts. Don't have too much of it, because I've had too many of these where it runs down the capstan, perhaps gets to the flywheel, and then it sprays itself all over the inside of the machine. I recall I had a little Akai GX77, if I recall, that someone had completely swamped the spooling, the capstans in lubricant, and then had thrown itself all the way over the inside of the machine. It took longer to clean that up than it did to fix the faults on them. The only problem with this the Kluber stuff is that the minimum they sell it in is 1 litre tins, And each of these tins is about $200. So I took a great big deep breath when I went for when I bought this stuff. But that's something that you'll need to consider. I do sell it on my website in smaller 10 ml bottles, and quite honestly, 10 millilitres is more than enough you'll need to maintain your machine, even if you are completely stripping it down and just lubricating the rotational parts. Just put those out the way for a minute. Other tools that you might need, tapes, of course. We need a good old line-up tapes. Again, I'm not talking about too much about those, but frankly, if you're doing a line-up and getting your machine finely tweaked, you will need a line-up tape. And I said I've spoken more about those in webinar 1. Other particular tapes that you might create for yourself. This one is a small 5-inch reel. Just hold that up to the camera there. That's all it is a channel ident tape. I just made that. It's at 15 nips, and it just has a different tone on each channel. It's great just to put on and say, yep, what I know is coming off the left head is going to the left output, and vice versa. Here's another particular tape that I made a long time ago. It's just called test tape music. All that consists of is two speeds. I think it's 4 pieces of music of a minute each, and there's a variety of music. There's some rock, there's some classical, there's some organ music, all designed so to give the audio amps a workout. And it's a minute each, and the first band is at 15 nips and the second is at 7.5. I know the music and what it sounds like on these tapes inside out now. So when I put these on, this is my final test tape music. This was made on a Studio A80 in about 1989, 1990, if I recall, and it's one of the few things I kept before I went back into tape machine maintenance. As I said, I did dispose of all my manuals in about 2000, but I kept this and I still use it. It's on SM468 tape, by the way, or Zonal 675. Doesn't suffer some sticky shed, so it's great for that. These are the kind of things that you can make up yourself as you go along. Here's another particular thing I've made up. This is a lead, and all it is, it's wired to the connector, the same head block wiring as any Studer tape machine. You can take the head block off and you'll find this particular connector underneath on all what I call silver deck machines, A810s, A807s, A820s. If you've got a multi-track machine, A800, A820 multi-track, you'll just find 3 of these connectors under the head block. And it's just got some audio connectors here. And what it actually allows me to do is to inject some tone straight the way into here, into the head block and to the replay amps. If I was working on a replay amp and I wanted to put a test tape on with some tone, I'll be shuttling it backwards and forwards. What's it doing? What's the levels coming off of it? I'm shuttling the machine backwards and forwards, and I'm wondering, is it actually the head that's worn or the cards at fault? I can just plug into this. It doesn't harm the machine, by the way. Just plug this straight away in and inject the tone. You will see the crazy equalization curve, as we call it, the EQ curve, the response curve of the amp when you do that. You'll see how bell-shaped it is. It's all to do with magnetics and the tape contact with the head. How it's completely strange that you think this amplifier has not got a flat response at all, but it's quite fascinating. Things like that are useful to make up. Ronald Steinhardt, you might have heard of him. He's on a lot on the Facebook posts. He's making extender cards for, in this case, B67. I believe he's making them for Telefunken machines and other Studers. This allows you just to plug the card, this in place of the card slot, and plug the card in at the top. All it is, I say all it is, I think I do praise Ronald for doing this and to taking the time to design it, but all it is 2 connectors with on a PCB board with a lot of tracks. It allows you to test and maintain the cards when they're out of the machine, so to speak, but they're still powered up by the machine. Other things you might want to get into, stuff I would make up if we're doing tape tensions and you want to know what your brakes are doing to maintain those. The manuals will talk about a loop of tape around a reel. We'll just make one up from an empty reel. You've got it already. You don't need to make it up from scratch. And then you've got a few, if you look in here, spring balances, which are standard spring balances. You'll find these online. Just look for Amazon. I'm sure sell them. Amazon sell everything nowadays. And that is a particular one goes to 1,000 grams, a kilogram. It's what I use to to check the brake tensions or brake readings when I'm pulling the tape out. And these are various other smaller spring balances here. What else do we have? Steve Fenson, if you've heard of him, he's another chap. He's based in the UK. He's doing some great work with Studer machines. He's got a whole collection of them, and I spoke to him on one of the podcast episodes that I produce. And he's creating a new MPU board for the A810, A820 machines. I've got one, and they're fantastic boards, so they slot it into an A810 perfectly. He's also making these, which are copies of the guides that Studer used to make for doing tape tensions and adjusting them with the tension roller goes through here. You lace up the machine, and it's just you read off the measurements. I used to use, and if you don't want to invest in something like that, and this is applicable to any of your any machine, I just used to use a couple of rulers here, and all I've done is marked off on the on the requisite places at 53 millimeters and 73. You'll read those in the manual, put a ruler down, and set your tensions and adjust your tensions so that they're these particular marks. Simple, 2 small rulers, that's all they are, a couple of tapes, a couple of marks on the tapes, and you're sorted there. Other thing I should mention, get yourself a cheap digital voltmeter. They are, you know, $10, $12, even for ones that nowadays will read frequency if you really want to, but this one will do capacitance. Oh no, it won't do capacitance. I do have one that does capacitance. I've got several that will do the job. You know, it'll do your volts, your DC volts, it'll do your up to your mains volts and AC, and also your current. Very, very cheap. Just run on a 9-volt battery, no problem at all. If you're starting to get serious to support your machines with tape tensions, I went long and hard to find one of these. This is a tensilometer. They're American design, and they're used to measure tape tensions. Unfortunately, they're no longer made. I searched for about 6 months on eBay to find one of these, and I paid $250 for it. It did come with a box, and indeed, if you know about the tensilometer, it came even with the little calibration weight that you need. These are put onto the tape path. For instance, if you're doing the tape tensions from a supply reel, it's put between the supply reel and the tension arm, and the tape fits through these 3 little prongs here. And as you might be able to see as I move it, I don't think, yes, you can see it. There you are. That's me moving. It should really do that, but waggling it around, but I'm doing that for the purposes of this webinar. You put that on the tape and you put the machine into play, and it will tell you how many grams of tape tension you have. And you do the same on the same position on the take-up spool, between the take-up spool and the tension arm. You need to calibrate it. This one with its 3 prongs will do up to 2-inch tape, so for multi-track, but you have various tape widths and the weight, so you need to run that through and make sure that the needle is calibrated correctly before doing your tape tensions. I said, unfortunately, no longer made. You do need to get the right particular one as well. This is a T2H20, which is designed for tape machines, because they did others for video machines, VHS video recorders, even Betamax, if you know that your machine's there. They are the particular one. In theory, for tape, in theory, you could use one of their models, but just try and go for the proper one. I said, not cheap. That cost me $250 from the States, and it took me 6 months to find it. So really, there's some of the tools that you would need. The bulk standard ones that you can get in any hardware store, any electrical factors, through to things that you can make yourself that will make your job easier. The tools for the job. Oh, I forgot to say as well. I've got this on the bench downstairs in my workshop at the moment. This is a Tascam 388 Studio 8. Just bend down here and show you. This is what another tool for the job. This is what I use to move it around. A little trolley, because it weighs an absolute ton. And I would also, if you've got a large machine and you're taking it out the trolley, be aware if you're unscrewing it that the weight distribution can sometimes kick and go with you. I have to take a deep breath and be like sort of one of these sumo wrestlers before I lift this onto the workbench. And this made me smile as well. I'll just put this on the larger screen for you. I saw this on Facebook, one of the Facebook forums, and I thought it was quite nice because the poster had put, "My tech is getting on a little bit, and he has trouble lifting," and he made these kind of arms to that screw on. You've got the two screws that go into the machine there, which just onto the side panel. So they unscrew, and you can put these arms on just to help his poor old technician who's looking after this machine to lift it up. Crikey, I mean, I'm 55 in a couple of days' time, and I really know how he feels actually with getting those arms, because again, it's like brace as you lift these machines off the floor. Rules of halves. This is where we move on to some practical stuff. Let's look at a typical layout of a tape machine. If you've been on the webinars before, you might recognize this diagram. I've added to it recently with a little meter down the bottom here. This is a record and replay erase chain. And you get questions from clients, and I've seen them on the forum say, "My machine doesn't replay. I can't hear anything coming out of it." Now, if we look at this schematic diagram before we get anything down into capacitors and resistors and all those kind of things that make a tape machine work, all of these little triangles are a number of amplifiers. As we can see here, we've got the tape coming down on the right-hand side here. The first thing it meets is our erase head, and our erase head is driven by our oscillator. I mentioned that earlier, and our bias amp, and we can adjust that erase level here so we know it records properly. We've got a record side. We're injecting our audio in here into a line level. We go through to record level, our equalization curve where you're adjusting the bass or the treble. It's mixed here with our our bias oscillator frequency, and then goes into our record drive and our head. Tape moves down, finds the replay head, and comes off through the EQ and replay, basically the opposite of the input or the record chain to the output. So if you say, "Oh, my machine is not recording," and then you look in entirety where of the schematic diagram of a tape machine, and imagine you've got your service manual and you stuck all those different circuit diagrams together, and you're in this huge great mess of spaghetti almost with wires going everywhere. It's dead easy to just to become overwhelmed with it. So invoke the rules of halves. My machine doesn't record. Okay, so the first thing you want to do is to ask yourself is, does it replay? Get your pre-recorded tape, perhaps one, not necessarily a precious one like this, but you can get some old gash tape or some old tape that you know has got some known audio on there. Stick it on the machine, and we find it replays perfectly. We find it comes off the head, we can hear it at the output, we can see the meter moving. We've invoked our rule of halves. We've jumped straight in at this point here, and we've, by going halfway along a recording chain from our input to our output, we've jumped straight in here, we've put a replay tape on, and we've isolated half of the problem straight away, our rule of halves. We know it replays fine, so this part of the machine is likely to be okay. So we've got all this lot up here. You think, well, we've got a recording problem. What could it be here? If you turn your attention to this section here where I've got the tape source, you might find that's called, tape or source or replay. It depends on how it's labeled on your machine. It also depends where it is in the circuit. But what it would basically do is either loop the input through to the output, or in some machines, and I'll show you a PR99 in a minute, it loops it through to the monitoring side, the headphone output of the machine. Either way, you're hearing the signal that's coming into the machine. So if you then jump along here, we've got this whole section here, rather than plodding along and working through what amp could it be, we can switch switch it to source to tape, and we find that the audio is coming back out the replay. So we've instantly, with a few checks, we know that our line in amp is likely to be okay. The next thing we could do, we've got this section here. Put a tape on that you're willing to lose, that you know you want to record on, but have some pre-recorded material on it, and just put the machine into record. And what does it do? Replay that afterwards. If it's gone silent, but there's nothing else on there, i.e. the machine isn't recording the audio, but the machine has silenced the tape. It must mean that our erase side of the machine is probably working okay, because we know this section here is erasing the tape, which is not putting any audio onto the machine, onto the tape. Conversely, you might find it has put the audio on there, but it's mixed in with the other material that was previously on the tape. Chances are then it could be that your oscillator side is not working properly, especially if it sounds distorted. It's likely to be, there could be a problem with our mixing of our bias signal through to our record head, or I said it's not getting to this part onto the erase head and not erasing the tape. So again, invoking a rule of halves, we can quickly block down and find out what part of the machine is actually faulty before we even take the covers off. I just switch you to this the image here, to this Revox PR99. This machine is faulty, and I will also tell you now, I don't quite know what's wrong with it at the moment, but I'm going to invoke the rule of halves. What it's not doing is we're not recording properly. If you notice down here, you've got your input and source switch, and I've got some tone going into the machine. We turn our attention to the VU meters there. Apologies, there's a little bit of light glare, but you can see there, if I just switch it on and off, you've got some tone coming in. So just to go back to our diagram here, we can see that we've got tone that's coming in on the input side, and it's going through the line in amp, and it's coming to line output amp, and I can see that on my VU meters. So I'm, reasonably happy that that part of the machine is working okay. If I just switch it to reproduce and then put the machine into play, this has got some pre-recorded material on here, and as you can see, it's only coming out on one channel. But don't be fooled by that. Is that actually the machine replaying it? Well, the way you can check that is just put pause. If that meter was kicking on, for all we know, it could be an electrical problem in the machine, and that's just making the meter wag around. Yes, you can also listen on your headphones. That's a good example. But here I'm just demonstrating by doing a few simple checks that we can see we've got an issue there, that the meters are kicking around, not really properly. If I just go into record, play and record, you see our two red lights are coming on there. There we are, that's our tone going in. You can see the two meters there. If I switch it off, we have lost our left channel. And also notice that this meter here is not, it should be there solid tone like that. It's clearly the audio that's on the original tape. The machine, although we've got our red lights on here and here, is not erasing the tape. You could be checking the obvious and check the heads. Is there muck on the heads? I have seen editing tape and the sticky tape that's used in editing, splicing tape, stuck on the heads before, which can stop it. So much gunk on the heads, which could be stopping the problem. But by doing these simple checks here, we have checked that we know the machine replays okay, and it's got a record problem. I suspect there's a problem with the oscillator, the bias oscillator. Again, before I jump straight in and start taking the components out and recapping the thing, simple things like just take the oscillator board out and reseat it. Or if your machine doesn't allow you to do that, perhaps you can, by looking at the circuit diagrams, disconnect a couple of the wires off the circuit board and isolate that section. I said what's on the machine that's good. I would have done these checks beforehand anyway to make sure that the machine is working properly. The other thing you might notice about this machine as well, I pointed out, hasn't got a main switch on it. This is another fault that's on there. If you are moving these machines around, B77s and PR99s are the same. The main switch under there has got live terminals on there, and that's actually about the last time I got a belt off one of these machines, because I lifted it like this and put my fingers underneath it. So word from the wise there. I'd actually safely wire the mains together on this machine, because I'm waiting for the main switch to arrive. Common problem on these Revoxes of this age, they wear and the switches get completely jammed over, and then they with the effort of turning them on and off, they break. You'll notice though, with everything else on this machine, what's working on the machine is good. You can see it rewinds okay. I can do a zero lock on it, and hopefully it'll won't run out of tape. I hope not. It'll happily do that. Yeah, there we are, it's doing a zero lock. So we can do a lot of checks before we start taking the covers off. So invoking a rule of halves to isolate the problem down. This particular machine, I said earlier, was with a hi-fi engine. And sometimes you have to use manuals that aren't in your native language. This is an ASC machine from, it shows the age of it, it was built in West Germany, so built prior to 1989, if I recall. The only manual I could get in it was in German. It had a problem on it. The owner brought it in, and there was two things wrong with it. Firstly, there was no counter. It was playing, but this take-up motor was always working. It wasn't spinning around rapidly, but you could feel it. It was just going, it was clunking its way around. So you likely think, you know, what's working on the machine and what isn't, invoking that, doing a rule of halves. It is playing. I very much think it's the first area to look at is on the power supply. Let's see if we can get that working, and checking the supply. There was no fuses that were an issue. There was a voltage regulator that had failed. It was the voltage coming out of it completely low. I changed it, and the counter burst into life. But we still had this rotational action of the take-up motor. Everything else is working. You could get the machine to play, rewind, do all these things, but when it's sat without any tape, you could just see this thing clonking around. So I'm thinking very much likely to be the drive of the motor. We know the motor's okay because it fast forwards and rewinds. It's working on this machine. And I'm happily working on it when there was an onboard fuse that went pop on the thing. I thought, oh, that's interesting. And the machine, the two spooling motors died, completely died. And that fuse was protecting the 125 volts. As a point of interest here, ASC used the same PAPS motors that Studer and Reeboks used. I mean, it's a lovely machine. It's built like a tank. It's a nice nice design, really. And I quite liked it. But they use the same 125 volts, and they've got this fuse to protect it. And the fuse had gone. But I thought, well, it can't be the fuse, the original fuse blowing, because the other motor was still working happily. There was some DC to AC triacs in the components in the circuit, which I noticed it was duplicated between each motor. I took them off. They actually sit on a heat sink on top of the machine there, and just swapped them over. And the fault, after replacing the fuse, went straight back to that motor. So it isolated the problem. So replaced that device and put the fuse back in, and the machine is working. But as you can see there, it came in as completely dead, but I don't believe the original fault was the regulator on the power supply failing. I believe that device that does the spooling motor had failed, and what happened is it failed partially open. So that's why the motor was constantly working, but not spinning rapidly. It had failed, and therefore the motor's constantly running. The power supply was having to supply this all the time, regardless of what the machine was doing. And then it too failed, because after that, all the display died. So the original problem wasn't actually, it was the effect rather than the cause of the issue. So sometimes you will find that there are stages to go through. I had a way back, probably about 18 months ago now, time flies so, Studio A810 had 7 faults on it. As fast as you work through one, it was like pushing doors down. You fixed one fault and you found the next one had failed. Sometimes, remember, it's not, for instance, a loss of power, a loss of DC power to a board isn't the fault of the loss of the DC. It's the board that it's supplying might have what we call gone short circuit or pulling the volts low. So the power supply, once you disconnect that board, bursts back into life and everything's fine. You think, well, the power supply is fine, plug it in, the machine dies again. So rather than you thinking it's the power supply that's faulty, it's the poor work that the power supply's got to do, the load it's trying to drive into has gone faulty. This is one area you'll find with machines, is break it down, these rule of halves, these 7 problems I had. I was working, right, I'll go for the middle. I know that, oh, the power's working to this board. I unplug various other parts of the board downstream. It works. I plug it back in, it dies. So we move on, rather than laboriously going through each problem. Operate outside the box. Here's another video for you. And it's of a B77 that was brought in. The owner sent me this video, and it's a short one, but it wouldn't go into play. So I'll just show you that. Put that on the screen for you. As you can see, he's pressing the buttons and nothing's happening. Pinch roller's not pulling in, there's nothing. That, if we move on, I had a pretty good idea of what it was after sort of doing what's working on the machine and what isn't. The power supply was fine. It was clearly that the push buttons were not supplying the correct commands to this device here. This is IC4, this big device here. These are all the push buttons at the top here, and they just do closing contacts down to our device here, which also takes in other information. There's the end of tape switch and there's the editing switch there. If you've got a B77, you'll find that it's got a sliding switch on front of the heads. It's that switch there. Takes all these commands in and then dishes them out to the spooling motors and other machine, other product, the pinch roller solenoid, and puts all those commands out down there. And I had an idea that these, although they were making contact because all the switches were working, the chances, and again, you think there's what, 5 or 6 switches here, all of them are faulty. I can't believe that. But the machine is being held in a state that it's not taking commands in. If you look at these capacitors down here, if we just move on here, I replaced all of these. Okay, I did a partial recap on the machine and it burst into life. Everything's fine and it worked perfectly. Everything's sweetness and light. I always soak test the machine, so after a lineup, I put the machine into soak and it was fine. I had it plugged into the wall, and there's another socket next to it with a switch on it that I needed to plug in, another device. And as I switched that switch over, that particular B77 just stopped. It just stopped playing. I thought, oh, that's interesting. Power's on, all the capstan's moving. Oh, that's interesting. So I switched the power back on, not on the machine. It still had it on the switch on the mains again, and it burst into fast forward. I thought, oh, interesting. So I then went to the power switch on the machine and switched that off, and then switched it back on, and it then went into record. And clearly, the machine, the action of applying mains to the machine was giving erroneous commands to our device down here. If I hadn't had the machine running with tape on it, I just put it into play and yes, it rewinds, it fast forwards, taken the tape off, here we are, customer, here's your machine, it would have gone out with that fault. But because I operated the machine, as I say, outside the box, i.e. I had the tape machine laced up with tape and I had the machine switched off, and then I just switched it on from the mains and saw it did something wrong. I knew what the problem was, I've had it before. It's that capacitor up there, because this is the 5 volts which drives the this chip, and on here I'd already replaced this one, but clearly the 24 volts coming in at the top here was not smoothed properly by our smoothing capacitors, and it was giving erroneous results on the erroneous commands, I should say, or this chip was interpreting as though these switches were being pressed and the machine was going into play. So this is what I say about operating outside the box. Do that with your machines. Work them how they would not normally be used. Let's go back to our PR99 here. This is a tip I always tell to people if you're planning on buying a machine or you just want to investigate it. Use the machine in a way that you wouldn't normally use it. Here we are, we're going into fast forward. I'm going to go straight into rewind now. There we are. I wouldn't normally do this, but it's got it up to speed. I'm going into fast forward now. I'm going back into rewind. And now I'm going to go straight into play and see what it does. Use the machine in a way you wouldn't normally expect to use it. Give it a bit of a workout, because sometimes that will throw up issues that, that you hadn't seen if you were using the machine, frankly, as the manufacturer intended. The other thing you can do, and approach to fault finding, ask yourself what has changed. What has changed on this machine since it was working properly, or I was told it was working properly, to it's being in its faulty state now. You do read these issues, and sometimes they are. You think, well, yeah, they're a little bit head scratching. But people say, I stopped playing the machine, and now it just won't turn on anymore, and I don't know what it's doing. But ask yourself what it was doing beforehand. Little story here. I had a customer who had a TIAC and a Revox, and he spent, a fair amount of money, and I spent a fair amount of time servicing these machines, and they work perfectly. I soak test all my machines before they go out, and it was all fine. Picked up the machines. Thank you very much, Ian. I'll take them away. Really pleased with them. He called me about 3 days later and said, "Your machines, they're awful. There's no response on them. They're muddy. It's screeching. Both of them are doing exactly the same thing. I'm not very happy." And I said, "Well, fine. I do apologise for this. We do have to accept sometimes that machines, they're like vintage cars, and you get faults on these these machines, and people say, what is the fault?" Unfortunately, with the age of these machines, sometimes, just as like I had that Studer with its 7 problems I'm knocking down, there isn't one fault, there's several. And sometimes you can fix a machine, soak test it, and a fault does come back. It's unfortunate. But I'm thinking to myself, 2 machines are doing exactly the same problem. And he said they instantly went wrong, and this is what's wrong with them. So I said, well, please bring them back. I'll look at them again for you free of charge, and I do apologise for the problem we got. So I got them on the bench. And there we are. That's the first thing I saw on the TIAC he had given me. That is why it was a muddy response and screeching, and that is the Revox. I did point out the kind of tapes, what kind of tapes was he using, because I suspected when he said the tapes were screeching, what has changed? He's played 1 tape on each machine. That's the only thing that's changed from switching this thing on, and within minutes the machines have been reduced to screeching and dull response. For the simple things such as sticky shed syndrome, in a massive way. As you can see, it's completely built up all over the heads, and the poor old machine doesn't stand a chance. Ask yourself, what's changed? That's about it for your fault finding techniques. We've been running now for about an hour and a bit or so, or an hour and 5 minutes. If you have some questions, I have a couple coming in, and I've also got some other ones that were sent to me earlier. I'll happily go through with them with you. A couple here I have a TIAC 3340, and the erase head doesn't fully erase. You can hardly hear the previous recording. Is that a tape issue or an erase head issue? Could it just need demagnetizing? Demagnetizing isn't quite up there with head relapse and head wear and recapping, but it is a thing that's rolled out by a lot of people. Demag your heads. That's going to solve the problem. Yes, you can use your demagger, and I do recommend demagging your machines every so often. I demag machines every time they come in before I work on them, because I don't know the state of them. But if you have got a machine and you're keeping it running, frankly, even with average use, demagging every 3 months will be absolutely fine. Do it properly. I showed you in webinar 1 how I demag, and you mustn't turn the demagger on and off near the tape head. You can invoke a permanent magnetic charge to them. But I have to say that no amount of demagging is going to restore the erase function on this machine. You would also think as well, if the head is so magnetized that it needs demagging, put any tape on there, it's probably going to start partially erasing the tape anyway. No, you've got to look there at the erase issue. Again, let's invoke a rule of halves. Does the machine replay a pre-recorded tape happily? If that's good, let's go and see what it does with some a tape that's had some material on that you don't mind wiping off, and see what the machine makes of that. Then work the way down. The fact you say the erase head doesn't fully erase, I suspect it is the erase head area. I will be looking at the bias oscillator. I will be looking at the simple things such as, is the erase head okay? I have had a machine where I had a lump taken out of an erase head, and I very nearly put a line-up tape on it before I saw it. Luckily, I put some old gash tape on, because it promptly stripped the tape. It shredded the tape with this piece of plastic or metal that was sticking out of the erase head. How it happened, I don't know. But I will be looking at the erase head. Is it clean? Is it doing its job? Is it in contact with the tape? Is it set up properly? Those things that you can do. prior to ever getting the cover off. Then I'll be looking at the bias oscillator, and also is the erase signal there. You can use that with it, check that with an oscilloscope, and work from there. But that is the area that I'd first start looking at on the erase side. There's another one here. My A77 is not functioning, and I can hear the audio input to it. And when I press record, the VU meters light up. At playback, there is nothing on the tape, despite what was there before recording. Well, you can see there that you can hear audio input. Perhaps if you're doing your source and tape switch, that's good stuff. You can know that the audio is getting into the machine. Your VU meters lighting up to show that the machine is going into record, just as we've got with our PR99 here. When I put that into record, it's quite a good example of what this PR99 is doing. Actually, just because your lights are coming on to say it's recording doesn't actually mean that the machine is recording. These are driven in a variety of ways by tape machines. Some are driven in tandem with the bias oscillator firing up when you put them into record. Others might be relays which click over when you press the record button to let that bias voltage into the record head. I would be looking there. You know that your VU meters are working, or the indications to say it's recording are working behind the VU meters, but there's nothing on the tape. Again, invoke the rule of halves, pre-recorded tape, take it from there, narrow it down. The next thing I would do is, after you've got the covers off on those machines, all of the cards are down the bottom. We're fortunate on those machines that you can take all the cards out. Sometimes I would just literally take those cards out and see with my contact cleaner, give those edge connectors a clean, or the pins on an A77, give them a clean and reseat the cards, and you'll be surprised sometimes the whole thing bursts back into life. It might not be the audio that's got dirty pins, it could be some control voltages on the machine or supply voltages to the amplifier that are stopping the machine going into record. Josh has put a question here. Hi Ian, could you supply a list of products that you earlier suggested for easy reference? Yes, you're probably talking about all my lithium grease and my platinum cleaner. Obviously I'm UK based. I don't know whether these actual brands are available where you might be. I know if you know CPC, Farnell CPC, this is ProPower is their own brand. I think Farnell do operate in the States, but ProPower is their own brand, and indeed I buy this AF Platinum Clean off of CPC. It's just easier for me to do it and order it online. But yes, I will get a list together of those products that I use and get that to you. That is part of you being and I thank you so much for buying a ticket to this webinar. I will supply that information to you, obviously via email after the event, and indeed the webinar is being recorded, and I will send you a private link so you can watch it again. What else have we got here? There was a few other things here. I've got a fuse blowing problem, or vibrating and chattering on a solenoid when in reverse play. I don't quite know what this is, but clearly reverse play, we're talking obviously about machines such as an Akai, or I should say a TIAC or an Akai that have got the reverse function, X1000R or something like that. Yeah, so fuse blowing symptom and possibly a vibrating or chattering FR, forward reverse solenoid, when in reverse play. Well, again, the first thing, you've got fuses blowing. Clearly, it might not be the power supply. It could be what the poor old power supply is trying to drive. So again, the first thing I would do there, let's invoke a rule of halves. Let's approach that. And if you can safely do so and get some insulation tape around the wires, disconnect that power supply, it's still in the machine, from what it's supplying, and just see what the volts are doing there. So in other words, power the machine up. The power supply is just sitting there. Perhaps if it's running the audio electronics, and that's fine, just let it supply the audio electronics, but not the mechanics to drive the forward and reverse solenoid or the spooling motors, and just see what voltages you've got coming out that power supply. And again, leave it on for a while, that make sure it's warmed through. You can find with good old capacitors, they will start off, if they're starting to age, at one value, and as they get warm and as the power runs through them or what have you, they do start to change, and in the end they go pop. Incidentally, people do ask me, if I've got my tape machine, should I switch it off or leave it on? Every time you power a tape machine up, you're straining the components on it. And the older these machines get, this is when people obviously talk about the good old riffer bombs. Oh, I switched my machine on, there's a great puff of smoke and will come back out of it. Yeah, that's because the good old riffers are being kicked with some electricity and the poor old things on their last legs and go bang. You strain a machine every time every time you switch it on. The downside, of course, is every time there's warmth and power going through these machines, it's aging the components as well. It's a trade-off, it really is. My advice, if you're an occasional listener, perhaps once or twice a week, you put a tape onto your hi-fi and in your domestic environment, switch the machine off. If you're a professional user and you've got these machines running and there are workhorses, and perhaps you're doing a session, perhaps Monday to Friday, I would consider switching it on in the morning and leaving it on and turning it off at the end of the session and coming back. Do also, especially if you're using them professionally, switch that machine on well in advance, half an hour before you need it, just so everything's warmed its way through. You find even the warmth of the machine with all those amps in there, it makes all the lubricants start to just make that a little bit smoother on the mechanical parts, and it will run well. But yeah, I wouldn't suggest you go, oh, well, it's lunchtime, let's just switch the machine off and go for lunch and come back afterwards. On off every day. It's not doing the machine a lot of favors. So I've got another question here. I understand about aging of electronics. David's mentioned here. In your experience, do the heads go out of mechanical alignment over time? Well, obviously, they do wear, so that's a given. How quickly they wear depends on a number of factors. Obviously, how often you're using the machine, what tape formulation, and what speed you're running the tape, and also the actual alignment of the head. If a head is misaligned, it might be working perfectly okay, but it's then wearing an asymmetrical ridge into the head and will completely ruin it. I did have a TIAC. Which actually is the customer's is an X10, if I remember, and he said we've had to just basically junk the heads on it because there's a ridge worn in it, and when I align the heads correctly, the ridge is actually lifting the tape off on the top track, and therefore the HF response is appalling. Do they go misaligned over time? I'd say they only get misaligned over time if you are subjecting the machine to a lot of vibration. And this is especially with larger head machines, 16, 24 track machines. They're big old blocks. You stick those in the back of a truck, perhaps you've bought the machine and you're taking it back to your studio, and all that vibration, you can guarantee that it will probably be misaligned when it gets there. The same, probably a lot of the boards have shaken loose. This is what I thought, incidentally, with that machine, those two machines that the customer complained that weren't working properly, that perhaps he bounced them around in the back of his car when he was taking them home, and the heads had taken a hit. Smaller quarter-inch heads don't tend to suffer from that problem. However, I would still look, if you're transporting the machine, perhaps you're using it as a recording session, even a quarter-inch machine, do check the heads prior to you conducting that session. The machine will probably record perfectly, but of course, if the heads are misaligned, it means it's recording it misaligned onto the tape, and you'll need to only replay it back on that machine for correct reproduction. But no, my experience is they don't tend to move themselves unless your screws aren't tight enough. But in fact, you'll soon see that if they're so loose to move like that, as you lace the tape up, you might see the head physically move and the wrap goes out, or it's wobbling around. Well, that's clearly not aligned properly. Let me see, can silicone grease be used? Yes, I do use silicone grease, bearing in mind that it depends where you use it. Some silicones are better than others, and also maybe you'll be able to put me right on this. I can't remember if it's temperature dependent. You're not getting a massive amount of heat inside machines, but you do get heat on rotational parts, especially on capstan motors, and especially when you start to run these things at 15 and 30 IPS on the bigger machines. Just looking at our good old PDP 65 or GLY 2000, it's a high temperature oil. It's one of the reasons why Studer recommended it. You do get some heat on some of the bearings on capstan motors. It's not so, it's not like you can, wow, it's really hot. Although I have have had a machine recently, and I do know the person who owns it is on this webinar, where unfortunately we've had to say that the bearings on his capstan motor are not the best in the world, and they literally were so hot because they hadn't been lubricated properly. The poor old machine hadn't been had some TLC way before he bought it. The bearings had basically worn, and there's so much friction there, they are so hot. But Studer do recommend, and indeed any other manufacturer, for rotational parts, you use a high temperature lubricant. As regards silicone grease, I would say it's probably okay, but I would still stick to using it on sliding parts. And again, with like any lubricant, any oil, do not drown the thing. Do not have it so covered in. I do use cotton buds to apply the grease, and yes, I do. I will perhaps, just literally give a demonstration, squeeze some of this stuff out, and stick a dollop of it on like that, and just wipe it all over. But then I would wipe it off afterwards. You can see where the original grease was from the slide patterns on the mechanics, and you'll see a lot of that on machines, perhaps on the pinch roller pulley, or if you've got some machines that are single motor and they rely on a lot of sliding parts to do the fast forward and rewinding action, you'll just see where those grease patches are. So although I might sort of put some on, careful with the rubber parts of it, because you don't want grease on there, not just because it doesn't do the rubber any good, but because it's slipping, isn't it? You don't want that. But you can see where those patches are, and I just wipe it off afterwards, wipe the excess off, make sure it slides backwards and forwards, because you've got to get the grease in between the moving parts. You've got to separate those moving parts, and that should do the job. But I said, do not just pour so much stuff on there and drown it. That poor old GX77 I told you about earlier, where it literally had sprayed itself all the way over the inside of the machine, all over the circuit boards, all over the rubber, the belts, and it took me a long time to clean up. Got another question here. Can you still buy alignment tapes, playback levels, and check frequency response? If so, where? Well, the only place that I'd really recommend, I don't have no commercial tie-up with them, but MRL, Magnetic Research Laboratory, based in the United States, and to my knowledge, they've been making them since probably the Germans made tape machines probably. But anyway, you don't get a lot for your money. This is a 1/4-inch tape. And as you can see, it's a 3-tone version with azimuth, or you can get dual speed versions. So I prefer to buy the single speed version. So this is the let me see, yeah, 15. This is 15 IPS tape, and I've got a 7.5 IPS one, and I have got a 3 3/4 one, but I haven't used it in a long time. I don't like lining machines up to 3 3/4. I don't regard it as a professional standard, and I do tell people it's best endeavours on a 3 3/4. I'll do my best, but let's stick to 7.5. Let's stick to 15 IPS. 30 IPS again, unless the client wants it for studio use, but certainly not for consumer use. I don't tend to get involved. But MRL are the people to get them from. There is a bewildering stock code, product code on the side here, and I do not hope to try and explain it to you, and I do wonder whether MRL do. But MRL, Magnetic Research Labs, just Google them, and they have a lovely document you can download listing all of their products. I recommend get some short tones, 100 hertz, 1 kilohertz, which is your reference level, 10 kilohertz, 12.5 or so for your high frequency, and also there's a band for doing the azimuth, which is the only adjustment you do on your heads with the tape. The rest of it's all done mechanically. And use your tapes there, but make sure, and I can't stress this enough, make sure your machine is working properly mechanically before you ever introduce your very expensive. This is about $150 worth, and I have a 1/2 inch and a 1 inch tapes, line-up tapes, and the 1 inch tape cost me $800 to get into the UK, and even in the continental US, I doubt it, you're probably paying at least $650, $700 for them. Do make sure that the machine is behaving perfectly before you put your very expensive line-up tape on there. I would steer clear of anybody who's making line-up tapes. I'm afraid I'm dubious about what the history is. I did read one on their website that said on a carefully lined up Revox PR99. Well, I like the PR99. I don't know whether there was a long-going thread on one of the forums on Facebook where I contributed about whether a PR99 is a master recorder. But that aside, I like the PR99. I own one, but I'm sorry, it's not the kind of machine I would produce a lineup tape on that I will perhaps then take to a Studio A810 or an Atari machine, a sort of MX550 or anything like that, or a machine that I'm using, or an MCI or anything like that. A higher standing machine, so to speak. They're professional machines, and put that lineup tape on there. I just don't think it's up to the job. MRL have a long history of making lineup tapes. The machines they use, they work on, are probably adjusted to the nth degree to make sure the azimuth is correct, the speed's correct, and all the audio is fine. And that's why you can trust their lineup tapes. One more question here, and I think we'll move on. I've just got a couple more bits to do here. When cleaning, lubricating, greasing parts and surfaces, is there any common mistakes that users make that can affect operation? For example, I've seen some forum members recommend graphite spray to lubricate or unseat sliding mechanical parts. Is this good or bad or an idea of why? I wouldn't recommend graphite spray at all. I'm a student of modern history, and I visited the Middle East, and a friend of mine who lives over there said, yeah, I was living here when, and I'm afraid we're getting into current conflicts, but when the Israelis decided to bomb the power station with their graphite bomb, and all it does is a shower of graphite lands on the power station and blows itself to pieces. You're spraying graphite into your tape machine. I would say that's not a good idea because it's conductive and it can get everywhere. I really wouldn't do it. Graphite is a lubricant. There's there's that thing about you can use a sort of a pencil sometimes to make sort of certain rubber pencil on things, and that's graphite to make things smooth. I really wouldn't try and go for these sort of, let's call them left field or alternative ideas. We know there's modern greases and lubricants which are better than the stuff I was using 30 years ago, are available. And use them on the machines. Spraying graphite around in your machine is not something I would do at all, even if it's under control or you're spraying it on a cotton bud or a piece of cloth to wipe it on there. I really wouldn't do that. Not something I recommend. Stick to your good old lithium grease. Cracker, they've been making this stuff and sticking it on thousands of tape machines and thousands of CD player transports and all that kind of thing. The manufacturers know what works. So let's use that stuff. Same as Platin Clean for your rollers and your rubber parts. You've got a single motor machine that's got the rubber rollers around it. Use your good old Platin Clean. That said, this is better than the IPA-based stuff we used to use in the 1980s for cleaning rollers, and I wouldn't recommend. People say it's the end of the world if you've got your head cleaning spray on your roller's going to die. Yeah, if you repeatedly do it, it will dry the roller out prematurely. But this stuff is designed to go on rollers and it's fine. But you know, if we've got a better product, why not use that rather than the, shall we say, old traditional stuff? If you have any other questions, I'll be happy to answer them. Please send them in. Probably you could send them in via the inquiry form on my website, www.realresilience.co.uk. I don't, I'm afraid, operate a 24/7 answering service, but I'd be happy to answer those questions to you, perhaps, you know, sort of 48 hours, 72 hours later. But I do pride myself in getting back to everybody within a reasonable time. And if you don't hear from me, A, I apologize, and B, just give me another prompt email. I do get a lot of emails, a lot of queries every day, and I do try and work my way through them in a timely fashion. Finally, sometimes you've just got to give up. Just put this on the screen here. Sometimes machines are, and I do hate doing this when I'm the giver of bad news to an owner, and I'm afraid your patient has died on the table. This is a TIAC, is it? I think it is TIAC X1000. It was used in a swimming pool changing room for some reason. That's where it was used, and it was dead. All that would happen was the lights would come on a couple of controls on the display. The counter lights came on, but did nothing, and that's all it did. Well, I After doing what's working and what's good and finding there's nothing really good that's working on this machine, I took the cover off to find that it was absolutely rusty. And I'm afraid, in spite of trying to work on it, I'm afraid all of the processor board was corroded, and really the client did say, can we get a new processor board? I said, yeah, you can, but there's no guarantee that that's the problem. It could be another board that's corroded. It really was an utter slog to try and replace it, and I'm afraid we had to write the poor old machine off. So it's a great shame. And that happens sometimes. The patient dies on the table, and you've got to admit, you've got to realise that that you cannot take this any further. There's still some value in this for parts, and that's something we can still, perhaps this machine can live on, supporting its fellow X1000s in terms of the control knobs and the head block, perhaps. This is me, just to recap Real Resilience. There's the website, as you saw. There's my email, Facebook. You can find me on there. So that is it for this webinar. I do thank you very much for sending your questions along. Please keep sending them and I'll answer them. I hope you've got some useful information and takeaway from this. And I do thank you very much for attending.